Earthquakes. Earthquakes are one of the Earth's most common and impactful natural phenomena, arising from the dynamic movements of the planet's tectonic plates. These plates, which make up the Earth's crust, are constantly in motion, albeit at a slow pace. However, at certain points known as fault lines, these plates can either collide, slide past each other, or pull apart. The energy that accumulates due to these movements is stored in the rocks at the edge of these plates. When the stress on the rock exceeds its internal strength, it breaks and releases energy in the form of seismic waves that propagate through the Earth's crust. This sudden release of energy causes the shaking that we perceive as an earthquake. The point within the Earth where the rock breaks is called the hypocenter, and the point directly above it on the surface is the epicenter. The impacts of earthquakes can be profound and varied, ranging from minor tremors that barely register to major quakes that can cause massive destruction, loss of life, and alter landscapes permanently. Secondary effects can include tsunamis, landslides, and even volcanic activity. The study of earthquakes and earthquake-prone areas aims to predict potential impacts and develop construction practices that can withstand earthquakes, ultimately reducing their destructive potential on human life and infrastructure. Tsunamis. Tsunamis are extraordinary sea waves generated primarily by seismic activities under the ocean floor, such as earthquakes, but can also be triggered by volcanic eruptions or landslides into a body of water. A tsunami is fundamentally different from typical ocean waves caused by wind. Rather, these waves are produced by the displacement of a large volume of water, often due to an abrupt shift in the sea floor during an earthquake. When the sea floor lifts or drops, it displaces the water above it, creating waves that travel outward in all directions. In deep water, these waves may appear small and harmless, but as they approach shallower waters and near coastlines, their speed decreases and their height increases dramatically. This process, known as shoaling, leads to the towering, powerful waves that characterize tsunamis as they make landfall. The impact of a tsunami can be catastrophic, with waves that inundate coastal areas, causing massive destruction and loss of life. Buildings, vehicles, and infrastructure can be swept away. The 2004 Indian Ocean tsunami, one of the deadliest in history, illustrated the devastating power of these waves, emphasizing the need for effective tsunami warning systems and evacuation plans to minimize the impact on coastal communities. Tsunamis remind us of the interconnectedness of the Earth's systems, where an underwater earthquake in one region can lead to far-reaching waves affecting distant shores.
Click subscribe to this channel to get more topics you love.
Volcanic eruptions. Volcanic eruptions are dramatic demonstrations of Earth's internal power, involving the expulsion of molten rock, ash, and gases from beneath the Earth's crust. These eruptions occur when there is an increase in pressure within a magma chamber beneath a volcano. This pressure can be caused by the accumulation of rising magma, which is lighter than the surrounding solid rock, and gases dissolved within it that expand as they near the surface. The nature of a volcanic eruption can vary widely. Some eruptions are effusive, producing relatively calm flows of lava that spread over large areas. Others are explosive, blasting rock, ash, and gas high into the atmosphere. The style of eruption depends on factors such as the magma's composition, temperature, and the amount of dissolved gases it contains. Magma rich in silica tends to produce more explosive eruptions due to its higher viscosity, which traps gases more effectively. Volcanic eruptions can have profound impacts, both locally and globally. Locally, they can obliterate landscapes, bury communities under ash, and disrupt ecosystems. Globally, significant eruptions can inject vast quantities of ash and sulfuric aerosols into the stratosphere, affecting climate patterns and lowering global temperatures. For instance, the 1815 eruption of Mount Tambora led to the year without a summer, causing widespread crop failures and famine. Understanding volcanic activity is crucial for predicting eruptions and mitigating their impacts on human populations and the environment. Volcanology, the study of volcanoes, integrates observations from geology, chemistry, and physics to forecast when and how volcanoes will erupt. Hurricanes, typhoons, and cyclones. Hurricanes, typhoons, and cyclones are all names for the same phenomenon: intense tropical storms that are among the most powerful weather events on Earth. They are known as hurricanes in the Atlantic and Northeast Pacific, typhoons in the Northwest Pacific, and cyclones in the South Pacific and Indian Ocean. These storms form over warm tropical oceans, where heat and moisture are abundant, conditions that are ideal for the development of these massive storm systems. The process begins when warm, moist air over the ocean rises and encounters cooler air above. This rising air causes a decrease in pressure at the surface, drawing more air in. As this air continues to warm and ascend, it cools and condenses, forming clouds and releasing latent heat, which in turn fuels the storm further. This cycle creates a structured system with a well-defined eye, the calm center, eye wall, the surrounding ring of intense winds and heavy rain, and spiral rain bands. The impact of these storms can be devastating due to high winds, heavy rainfall, and storm surges, a rise in sea level that floods coastal areas. The damage can obliterate infrastructure, devastate agriculture, and lead to significant loss of life and economic turmoil. Effective disaster preparedness and early warning systems are crucial in minimizing the damage from these powerful natural phenomena. The study of these storms and their paths helps meteorologists predict their movements and intensities, providing crucial forewarnings to potentially affected regions. Understanding the science behind these powerful storms is vital for improving response strategies and reducing their impact on human lives and communities. Tornadoes. Tornadoes are violently rotating columns of air that extend from a thunderstorm to the ground and are one of the most awe-inspiring and destructive weather phenomena. They can occur in many parts of the world but are most frequently observed in the United States, particularly in the Great Plains region, often referred to as Tornado Alley. Tornado formation is complex and influenced by several atmospheric conditions, but they generally develop from severe thunderstorms known as supercells. The genesis of a tornado begins with a change in wind direction and an increase in wind speed at different altitudes, which creates horizontal spinning effect in the lower atmosphere. This horizontal spinning air can be tilted into a vertical orientation by the updrafts within the supercell, which are powerful currents of rising air. As the updraft intensifies, it can tighten the spin and lower the pressure inside the vortex, forming a tornado. Tornadoes are rated based on their intensity, with the enhanced Fujita scale, EF scale, measuring their strength from EF0, which represents the weakest tornadoes, to EF5, which denotes the most powerful ones with wind speeds exceeding 200 miles per hour. The damage from tornadoes can be catastrophic, capable of flattening entire neighborhoods, uprooting trees, and hurling debris like deadly projectiles. Despite their power, tornadoes are usually short-lived and cover relatively small areas compared to other storm systems. However, their sudden occurrence and unpredictable path make them particularly dangerous. Advances in meteorology, including improved radar technology and predictive modeling, have enhanced the ability to forecast tornadoes, providing earlier warnings to residents and thereby helping to reduce casualties and damage. Floods. Floods represent one of the most common and widespread of natural disasters, impacting countless lives and landscapes each year. They occur when water overflows onto land that is usually dry. This overflow can be due to several reasons, including heavy rainfall that overwhelms the ground's ability to absorb it, sudden snowmelt, or water released from dams or other man-made structures exceeding their capacities. Rivers often flood when excessive rain or meltwater cannot be confined within the riverbanks. This is particularly common in areas where the banks are low or where the terrain naturally funnels water into a narrow channel, increasing the water level rapidly. In urban areas, impervious surfaces such as roads and pavements prevent water from being absorbed, leading to runoff that can quickly flood streets and homes. The consequences of floods can be devastating. damaging infrastructure, destroying crops, and displacing communities. Additionally, the standing water left by floods can lead to health hazards, including waterborne diseases and mold in homes. Effective flood management involves careful planning of land use, construction of barriers, and the development of early warning systems to reduce the impact on human life and economic assets. Droughts. Droughts are prolonged periods of abnormally low rainfall, leading to a severe water shortage. Unlike many other natural disasters that strike suddenly, droughts develop gradually and can persist for months or even years, subtly deepening their impact over time. They are typically caused by shifts in weather patterns that reduce precipitation over an area, often linked to larger climate phenomena like El Niño or La Niña. The effects of droughts extend broadly, from causing crops to fail and reducing water supplies to support agriculture, human consumption, and industrial activities, to natural ecosystems suffering as lakes and rivers dry up. Drought conditions can also lead to economic losses, increased food prices, and potential conflicts over dwindling water resources. Managing drought involves both short-term responses to reduce water usage and long-term strategies aimed at enhancing water conservation and storage, and improving the resilience of water supply systems to withstand periods of reduced rainfall. This may include the development of drought-resistant crop varieties, rainwater harvesting systems, and policies that promote efficient water use. Understanding the patterns and causes of droughts is crucial for predicting their occurrence and mitigating their effects. By integrating meteorological data with land and water management practices, communities can better prepare for and adapt to the challenges posed by drought conditions. Wildfires. Wildfires are large, uncontrolled fires that spread rapidly through vegetation, particularly in forested, brush, or grassland regions. These fires are fueled by a combination of dry conditions, wind, and heat. While wildfires can be caused naturally, such as by lightning, many are the result of human activities, including unattended campfires, discarded cigarettes, or intentional acts of arson. The dynamics of a wildfire depend heavily on the weather and the type of vegetation present. Dry, windy conditions can cause a wildfire to spread faster, increasing its intensity and the difficulty of controlling it. The presence of dense, dry vegetation provides ample fuel, which can lead to larger and hotter fires. These conditions are often exacerbated by climate change, which increases the frequency and severity of heat waves and dry spells. Wildfires not only cause immediate damage to homes and infrastructure but also have long-term ecological impacts. They can alter landscapes, reduce biodiversity, and disrupt ecosystems. However, wildfires also play a crucial role in some ecosystems, helping to clear dead material, fertilize the soil, and promote the regeneration of some plant species. Effective wildfire management includes prevention strategies, such as enforcing strict regulations on land use and fire safety, and preparedness measures like creating fire breaks and promoting community awareness. Additionally, improving emergency response strategies and technologies for detecting and combating wildfires is crucial to minimize their impact on both human and natural environments. Landslides. Landslides involve the movement of rock, earth, or debris down a slope. They can be triggered by several factors, including intense rainfall, earthquakes, volcanic activity, or human actions such as deforestation or construction that destabilize the ground. Landslides are particularly common in mountainous regions but can occur in any unstable sloped area. The mechanics of a landslide depend largely on the composition of the ground and the slope's steepness. Water plays a critical role by acting as a lubricant, reducing the friction that holds the soil together, and adding weight to the soil, which increases the gravitational pull downslope. Earthquakes can shake loose earth and rocks, initiating slides, especially in areas with loose or layered soils. The impact of landslides can be devastating. They can destroy homes, block roads, and change the course of rivers, leading to further flooding. They also pose a significant risk to life, particularly in densely populated mountainous regions. Prevention and mitigation strategies for landslides include geological surveys to assess landslide risk before construction, the installation of drainage systems to control water flow, and the reinforcement of slopes using terracing or retaining walls. Public awareness and evacuation plans are also vital in reducing casualties during landslide events. Blizzards. Blizzards are severe snowstorms characterized by strong, sustained winds of 35 miles per hour or more, heavy snowfall, and visibility less than a quarter mile for an extended period, typically 3 hours or more. These conditions combine to create a disorienting, dangerous environment that can immobilize regions, disrupt transport and communications, and increase the risk of accidents and hypothermia. The formation of a blizzard involves cold air at the surface, lots of moisture, and lift, which is usually provided by warm air trying to rise over cold air. These conditions are often found in the mid-latitudes where cold polar air meets warmer sea air at fronts. The intensity of the blizzard is exacerbated by the wind, which can create massive snowdrifts and dramatically decrease visibility. The impact of blizzards is not just immediate but can have lasting effects. The heavy snow can collapse roofs and down power lines, leading to extended power outages. The cold temperatures can cause burst pipes and infrastructure damage. Recovery from a blizzard can take days or weeks, depending on the severity and the area's preparedness. Preparedness for blizzards includes having proper insulation and heating systems in homes, emergency kits with food, water, and medical supplies, and plans for communication and evacuation if necessary. On a community and governmental level, effective snow removal, accurate weather forecasting, and public awareness campaigns are critical to minimize the impact of blizzards.